Okay guys, welcome to lesson 11 for day 2. Again, today is building off what we did yesterday with multiplying and dividing with rational expressions. Quick reminder that rational expressions are just another way to say fractions, okay? So today we are working with fractions, which I know is not everyone's favorite, but you guys can do this, okay? You are capable, so just stick with me, take your notes, all right? Make sure we do our homework, follow along. Now today what we're going to be doing with these fractions is adding and subtracting them. So adding and subtracting is going to be harder than multiplying and dividing, all right? So let's get started. Just to remind you how we add and subtract traditional fractions that only have numbers in them. Okay, this is what you guys did almost all of middle school. So example number 1 is really easy. Why is it easy? Because they already have a common denominator. If you have a common denominator, adding or subtracting fractions is a breeze. Because all you do is you add those numerators. 1 plus 2 gives me 3. You keep that denominator of 6, and then you just simplify. What can you divide them both by? By 3, so you end up with 1 over 2, 1/2 is your final answer. Okay? For example 2, this is a little bit tricky because they do not have a common denominator. Okay? However, what can both of those denominators turn into? Both of those denominators can multiply to 4. Okay? So, in my first fraction, 1/2, to get the denominator of 2 into 4, I'm going to multiply it by 2. But if you do something to the bottom of the fraction, you have to do it to the top of the fraction. So I'm also going to multiply the top by 2. My second fraction, I don't have to do anything because the common denominator is already there as 4. So now what I have is 2 over 4 minus 1 over 4. Do you see how here for this first fraction, I multiplied the 1 by 2 and I got 2. I multiplied the 2 by 2 and I got 4. So now that I have a common denominator, it's nice and easy. I subtract straight across the top. 2 minus 1 gives me 1. And then I keep my denominator of 4. And my final answer is 1/4. Okay, guys? Now these are just easy fractions. Okay, so these are the easy ones. Now we're going to kick it way up a notch, bringing in expressions and the letter X, things like that. But the main idea is still the same. Adding or subtracting fractions always centers around the LCD. And what is the LCD? The least common denominator. Okay? So that means that whatever you have on the bottom of the fraction has to be the same for both parts. Okay? Your denominator has to be the same. So, how do we find the least common denominator? Step 1. This is our favorite step, guys. I don't know if you've been noticing, but step 1 is almost always to factor everything. That's why the factoring that we did in chapter 9 and 10 is so important. Remember our 3 main ways of factoring: working backwards, difference of squares, GCF. So the first step is to factor all the denominators. Step 2, take one of each factor to get the LCD. Okay? So let's look at our example here. Find the LCD of 2 over 5x and 10. To find the least common denominator, I could care less about the numerators, right? I want the denominator, the least common denominator. So let me factor everything. 5x would just be 5 times x. 10 would be 2 times 5. Now, this is what we mean by step 3. Take one of each factor. There's a 5 in each one. I only need to take one of them. Okay? The x is only here, so I have to include it. The 2 is only here, so I have to include it. All right? So if there's only one factor, you have to include it. All right? But if the factor shows up twice, you only include it once. So notice that my LCD is 5 times x times 2. So that means my final LCD would be 10x. Okay, guys? Does that make sense? Hopefully you're kind of following along here. We are going to do some more examples, so you'll get a little bit more practice with it. Now that we know how to find the LCD, let's apply that with adding and subtracting. So let's think big picture here. Step 1, as always, is to factor everything. Step 2, get that common denominator. Step 3, you have to multiply the numerator and the denominator of each fraction by the same thing to get the LCD. Remember, this is like when I had 1/2. If I multiplied the denominator by 2, I had to multiply the numerator by 2. So that's what step 3 is telling us, okay, that to get that common denominator, whatever you do to the bottom, you have to do to the top. Step 4, once you have that common denominator, just add or subtract the numerators. Remember, the numerators are the top, so just add or subtract straight across the top. And step 5, keep that denominator the same. So whatever you have there on the bottom of the fraction, just keep it. Don't add it, don't subtract it, don't do anything to it, don't cross out, just leave it how it is. Okay? So here are the 5 steps. We're just going to do 5 examples now. That's it, and then we're done. Okay? We'll start off a little easier and we'll gradually work our way up. So here's my first one. Perform the indicated operation, which in this case is addition. Okay? So they're asking us to add. Step 1 is to factor everything. This is a more simple problem, so there's nothing to factor. The 3x, the 7x, you can't break them down any further. So step 2 is to find the least common denominator. So the LCD. All right, let's circle each unique factor. I'm going to circle the 3. Notice the x shows up twice. I only circle one of them. And I'm going to circle the 7. So that means my LCD is 21x. Okay, because 3 times x times 7 gives me 21x. So I know what my least common denominator is. So now I know that I want both of my fractions to have 21x on the bottom. Does that make sense? That's the whole point. You want that LCD, that least common denominator, to be on the bottom of both of your fractions. Now let's go to step 3. Multiply the numerator and the denominator to get the LCD. So let's start here with this fraction on the right. How do I turn 7x into 21x? What do I have to multiply by? I have to multiply by 3. So I multiply the denominator by 3. If I do it to the bottom, I have to do it to the top. So 7x times 3 gives me 21x. 5 times 3 gives me 15. Now let's look at this fraction on the left. How do I get 3x to multiply to 21x? I have to multiply by 7. And if I multiply the bottom by 7, I have to multiply the top by 7. So on the bottom, I have 21x, and in the top, I get 14. So that, guys, is how we do step 3. We've multiplied, we now have a common denominator. Step 4, add or subtract the numerators. So 14 plus 15 gives me 29. Step 5 is just to keep the denominator. The denominator is 21x. So boom, I just put 21x. And that, guys, is my final answer. 29 over 21x, okay? Remember, we like improper fractions in high school math, okay? We do not want mixed numbers. So don't go to mixed numbers, just leave it here just like that. All right? There's our first example. Let's go to the next one. Kicking it up a tiny little notch. So perform the indicated operation. Again, we are still adding, so we're going to need a common denominator. Here they're asking us to factor everything. So there's not much to factor, okay? Because what we want to factor are those numerators, all right? we do want to factor the denominators if it's a work backwards, but that 4, we're not going to factor that. So I'm going to have 4 over 5 times x plus 3 over 2 times x. Okay, so what can I turn both of my denominators into? I have to include that 5. Notice here, I have 2 x's that are pairs, so I have to include one of them. This x does not have a pair. So if it does not have a pair, you have to include it. Okay? So does that make sense? Do you see the difference here? This middle x with the squigglies underneath had a pair over here, so you only include one of the pair. But this second x, if it does not have a pair, you have to include it. Then this 2, same thing, we include that. So as of right now, my LCD is 10x squared, because I have 5 times x times 2. So that means I want both of the bottom of my fractions to be 10x squared plus something over 10x squared. So let's go back up to the top with my fraction on the right. How do I get 2x to turn into 10x squared? I have to multiply it by 5x. If you multiply the bottom, you have to multiply the top. So in the bottom, I get 10x squared. In the top, I get 15x. Now let's look at my fraction here on the left. How do I get 5x squared to multiply into 10x squared? I have to multiply by 2. And if I multiply the bottom by 2, I have to multiply the top by 2. So here in the bottom, I get 10x squared. In the numerator, I get 8. Okay? So my last step, well, second to last step, add or subtract the numerators. So 8 plus 15x. I cannot mix them. Okay? You cannot mix numbers and variables. So it's just 8 plus 15x. And step 5, keep my denominator the same, 10x squared. And here we go, guys. Final answer. Okay, so I know it's a little confusing, but hopefully you're able to follow these steps and see that you know how to do each of these steps. Okay, you might have to have these steps right next to you as you do the homework. All right, but keep those next to you. Just follow the steps and you guys know what to do. Here's our next example. Perform the indicated operation. Now this one's a little bit tricky because we don't have 2 fractions. But again, how do I turn that 4 into a fraction? Over 1. So step 1 is to factor. There's nothing to factor. Everything's as simple as it comes. We're done. Step 2 is to find a common denominator. So remember, this x plus 2 is in parentheses. So it counts as one term. So for my least common denominator, I circle the entire thing. X plus 2 is one of my factors, and 1 is one of my factors. Now, 1 can be invisible, so that just means that my least common denominator is going to be x plus 2. So that means that I want the bottom of both of my fractions to have x plus 2. So let's figure out how to make that happen. In the fraction on the right, 4 over 1, how do I take that 1 and turn it into x plus 2? I have to multiply it times x plus 2. And if you multiply the bottom, you have to multiply the top. And so 4 times x plus 2, okay guys, distribute that 4. 4 times x gives me 4x. 4 times 2 gives me 8. Okay, so in the denominator, we never want to distribute, but in the numerator, we do. So now let's look at the fraction on the left. My denominator is x plus 2. Do I have to do anything to turn it into x plus 2? No, it stays the same. So if the denominator stays the same, that means the numerator also stays the same. Okay, so now I have x over x plus 2. plus 4x plus 8 over x plus 2. So I've done step 3. Step 4, add or subtract the numerators. So x plus 4x plus 8. That would give me 5x plus 8. And then step 5, keep the denominator, x plus 2. And here we go, guys. Final answer. All right. So there we go. Sound good? I know it looks confusing, but it's not as bad as it looks. Okay, you guys can do this. Second to last example. Okay, step 1 is to factor everything. Here on the left, we're good to go. I am going to put the denominator in parentheses so that we remember that they're joined together. On the right, the 1 is good to go. Remember, we have a bit of a problem here. With 5 over x, you want the x to come in front. But you cannot just flip these. You have to do something else. You have to put a negative out in front, and then you can flip. Okay, guys? So what we should have is 3 over x minus 5 minus 1 over negative x minus 5. And keep in mind, this is really an invisible negative 1. So let's go to step 2 to find the LCD. So to find the LCD, notice here's a factor and here's the same factor. So I just take one of them. So x minus 5 is going to be part of my LCD. Negative 1 only shows up once, so that has to be part of my LCD. So my final LCD, and remember these are being multiplied, my final LCD would be negative 1 times x minus 5. So here is my final LCD, which means that I want the bottom of both of my fractions to be negative 1 x minus 5, negative 1 x minus 5. So let's go back to the beginning, okay? Here on the right, how do I get this denominator to turn into negative 1 x minus 5? I don't need to do anything. That's already the denominator. So I can keep the denominator, keep the numerator. Here on the right, how do I get x minus 5 to multiply to negative 1 x minus 5? I just have to multiply it by negative 1. If you do it to the bottom, you have to do it to the top. So now I have negative 3 over negative 1 times x minus 5. All right, so we've done step 3. Let's go to step 4. Add or subtract those numerators. Negative 3 minus 1 would just give me negative 4. And then step 5, keep my denominator, negative 1 x minus 5, and there is my final answer. Okay, guys, negative 4 over negative 1 x minus 5. Now, what you could do, since there's a negative in the numerator, negative in the denominator, you could cross those out and you could just have 4 over 1 x minus 5. So be aware of that in case that shows up on a test question, okay? Yes, this answer at the bottom is correct, but you can simplify it one step further. Okay, guys? So just be mindful of that. This was a really tricky problem. I totally get that because this has a lot of those like hidden things for you to remember that we don't use very often, like this flip here in the denominator, things like that. But we only have one more example. All right, guys, you got this. You're sticking with me. All right, last example. Step 1, factor everything. This is already factored. For the denominator, we're going to use GCF. So when I GCF, I end up with 1 over 3 x minus 2. This is already factored over here. My denominator, I'm just going to break apart to 2 times x times x. All right, guys, let's find the LCD. So, is there a 3 anywhere else? Nope. So I have to take the 3. Is there an x minus 2 anywhere else? Nope. So I have to take the x minus 2. Is there a 2 anywhere else? Nope. So I have to take the 2. The x does not have a partner on the other side. Remember, it would need a partner on this side, so I have to take it. This x does not have a partner, so I have to also take that one. Phew. Okay, guys, so this LCD is going to be intense. This LCD is going to be 6x squared times x minus 2. So a pretty long LCD here. But let's finish this up. Starting over here on the right, what am I missing? If this is 2x squared, how can I turn that into 6x squared times x minus 2? I am missing a lot, okay? So I have to multiply this by 3 times x minus 2. So I would multiply this times 3 times x minus 2. And if I multiply the denominator, that means I have to multiply the numerator times 3 times x minus 2. All right, and let me try to erase some of this so it's not as crowded. Okay, guys? But what we're doing is we're multiplying the denominator times 3 times x minus 2, and we're multiplying the numerator times 3 times x minus 2. So in the denominator, that's going to give me 6x squared, x minus 2. In the numerator, I'm just going to distribute, and I get 3x minus 6. All right, over here on the left, what am I missing to make this into 6x squared times x minus 2? I have the x minus 2, and I have the 3, so I'm just missing times 2x squared. If I do it to the bottom, I do it to the top. So I get 2x squared over 6x squared, x minus 2. All right, guys, last step. Add or subtract the numerators. So there's nothing that I can do there, guys, to add or subtract. So I'm just going to write 2x squared. Don't forget this minus has to distribute to both. Minus 3x, but then when you minus negative 6, it becomes plus 6. And then over, keep the same denominator, 6x squared times x minus 2. Oh boy, guys, I know that was a tough one, okay? I know these are tricky. I get that. This is a difficult lesson. We are going to have another day to practice this tomorrow, okay? But I'm glad you guys stuck with me. Your homework is short, okay? Notice your homework is only 4 problems. That's it. I get that each problem is long. I get that each problem is difficult. But you can do this, okay? Encourage yourselves, all right? Help your friends out. Put questions in Google Classroom in the comments, okay? I'll answer them. I'll help you out along the way. It's only 4 problems. Okay, guys, don't just give up. You can do this. This is what your homework looks like. Notice these 4, all right? 1, 2, 3, 4, that's it. And notice, these are easier, okay? These are easier than the examples we did. I chose to do more difficult examples so that now you look at your homework and it's like, oh, okay, I've got this. All right, guys? So hopefully you do feel that you've got this. Okay, here in number 9, don't forget to flip this around. All right, in order to flip that around, you put the negative 1 outside, and then you have t minus 3. Okay, again, any questions in Google Classroom? Thank you guys for joining me for this lesson, and I will see you all for the next one.